So 8.2, confidence intervals for means, not for proportions. What does that mean? All right. The mayor, here's an example. The mayor is interested in finding a 90% confidence interval for the mean number. Mean is average, right? For the average number of pounds of trash per person per week that is generated in the city. The study included 250 residents whose mean number of average number of pounds of trash generated per person per week was 37.3 pounds. Sounds like a lot, huh? Do each of us generate 37 pounds of trash every week? I don't know. Is that true? Do you have any feel for the numbers? I have no feel. It sounds like a lot to me. But I don't know. Not studied it close. And standard deviation, 8.7 pounds. Round answers to 3 decimal places where possible. Okay, so compute. We're going to compute a confidence interval on this. Now, that's what we did Monday night, right? Confidence intervals. How is this any different from what we did Monday night? That'll be the key question. That's always the battle on statistics exams, as you all are freshly aware. Recognition, right? How will you read this come, whatever it is, 3 weeks from now when we're taking this, our third exam, and recognize this as different from what we did last time? Doesn't it all kind of go in your minds and kind of all look the same? Yeah. So we've got a problem. So here's our question. How is this kind of a confidence interval question different than the last one? Here we go. Here's back to the last section. This is the last section we just finished. Last night's homework, right? 8.1. And this is also asking for a confidence interval. Do you see any differences? Confidence interval. What was I don't even remember what our answer was on this one. It was like, well, I don't even know. Anyway, it's a confidence interval. What are we talking about on this question? They're saying, I can't even see it there. Oh, there's proportion. See that word right there? Proportion. What's a proportion? It's like a percent or a decimal. It's a part of something, yeah. Right? If I said, what proportion of the class is going to get an A on the third exam? I don't know, maybe 20% of the class. That would be the proportion, the part of the class. So if you look back what we did last time, 8.1, they were all percentage problems. They were all proportions. They were like, what percent of the class is going to get an A? What percent of the class is going to get a B? What percent of the class is men? What percent of the class is women? What percent after percent after percent? That was 8.1. That's what last night's homework was all about. Now, 8.2 is not percentage. It's mean. That's like saying, what's the average score going to be on the next exam? What's the average age of students in this class? What's the average distance people live from campus in this class, etc., etc.? Those are averages, not proportions. See the difference? That's what you want to recognize. So as we read this question, and they go blah, 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 90% confidence interval, mean number. So mean is an average, it's not a percentage. So then we go, oh, we're talking about confidence interval for a mean, an average, not a confidence interval for a proportion. All right, so what that means is a little bit different buttons on your calculator. Almost the same, super similar, but slightly different. So let me show you where we go. We're going to go the same place pretty much the rest of the semester. You know that, right? What button am I going to hit first? Stat. And then I'm going to go over to tests, all the rest of the semester. But this time I'm going to go down to the t-test. Well, I think it's like the first one, isn't it? Second one? Is it the second one? Second one on the list. So we're not going to go way down. Oh, no, I'm sorry. I'm lying to you. We don't want t-tests. That's not right. We want, isn't there something called t-interval? T-interval. That's what, and I'll give you probably next week an exam 3 notes that'll have all this laid out, so you'll be able to identify what we're needing. But for now, t-interval. So hit t-interval, and when you do, the first question it's going to ask you, it's going to say data or stats. Is that what it says? Yeah, stats. Okay, for now, make sure you highlight stats. So move the cursor over to stats, hit enter on stats. You're telling it you're going to enter some stats. Hit enter on that, and then go down, and it's going to ask you for what? An X bar, and S sub X is going to say, what's X bar? Or let me bring it down here. It's going to say, what's X bar? What's S sub X? So what do you think X bar is? Yeah, X bar is always an average, huh? Do you see the average up there in the problem? Yeah, right there. The 37.3. Where's it? I don't even see the word average anywhere. Oh, there it is. Way back here. Mean number of pounds of trash generated per person per week. It's a lot of words. The mean is 37.3. So that's the average. And the standard deviation, that's the S sub X. That's the standard deviation. I think you probably already guessed that. 8.7. And then it's also asking me for N. What is N always? Total number of people in the sample, huh? And what's that for this problem? 250. 250. And then the confidence level is they're asking us to do a 0.90. So put that information in, and then hit enter for calculate. I'm getting 36.392, comma 38.208 for my confidence. Oh, and up here they want you to select T distribution. The option the homework will give you is T or Z. You want a T distribution. And then the confidence interval, do they say how many? Oh, 3 decimal places. So we'll put that in right here. 36.392 to 38.208. Is that making sense? So we are saying that we are 90% confident that the real average trash generated per person per week in the city is somewhere between 36.4 and 38.2 pounds. Is that making sense? You guys able to get that in the calculator? Hey, I have a question. What if somebody was reading this problem who didn't know really what we were doing, but wanted to be obstinate about it, or maybe just had a sincere question, and just sincerely asked, why are you saying that the mean number is between 36.4 whatever and 30.2? When it says right there, the mean is 37.3. The mean's 37.3. Why are you saying it's between 36 and 38? When it says right here, the mean is 37. Yeah, confidence level? What's that? Why are we saying that? Well, doesn't it say right here the mean is 37.3, and now you're telling me the mean is somewhere between 36 and 38? What do you mean? It's 37 right there. 37 is between. Yeah, 37 is between those, but why are you saying, why don't you just say it's 37? Why are you saying why don't I say it's between 30 and 40? It is. 37 is between 30 and 40. What, are you just making up numbers to say it's between? Because your calculator said so? Why is the calculator saying? What are you doing? Uh-oh, is it too hard of a question? I'm hoping you have an answer. Hoping you have a very clear couple of sentences to say to that. So this is what I'm afraid of as a teacher. This is my secret fear. That really I'm up here, it's not really secret, I'm saying it out loud all the time. And that is that I'm just going, wah, 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 the Charlie Brown teacher. And you guys are just like, whatever, just get those numbers down. And what I'm doing has nothing to do with the real world in your minds. That I'm making no connection to reality at all. And you're just moving numbers around on a page and hitting buttons on a calculator. We don't want to do that for 3 hours, 6 hours every week. What good is that? Let's just play hitting button games and writing down numbers. That's boring and ridiculous and useless. So let's get to reality. What is this? How would you answer that real question?
Can I try?
Yeah, please.
I would say that 37.3 is the average of the 250 residents, and we want a bigger average. We want an average of the whole.
Average of the whole. What do you mean average of the whole? So first off, let me hold right there, Bryce, right? Bryce?
Yeah.
Let me hold right there. That was a beautiful beginning to the answer, and you've almost got the whole thing, and I think you probably will get it. But let me first off say what Bryce just said, and make sure you heard it, because it was excellent. He's saying that 37.3 is the average for the 250 people. It's the average for the 250 people, right? Isn't that what the words say? Mm-hmm. Go on, Bryce. And then, okay, so now, Ty, you're about to talk to me about that then.
So those numbers are, we're 90% sure that the real average, or the average of the number of pounds of trash per week for the whole city, we're 90% sure that it's between 36.3 and 38.2.
So good. Beautiful. Did y'all hear that? That's excellent. Is everybody catching that? So Bryce is dialed into reality. Are you with him on this? Oh, Bryce is dialed into reality, right? He's catching. Are you with him? Right? This is the average for a sample of 250. And we're trying, remember, all we're doing in statistics, that's why this issue is so important. This is what we always do in stats, right? We take a small little group, and then we find their average, and we try to let that inform us what might be the average for the whole city. Or, the vote for the whole nation in November. That's what polling is. Or, on and on you go, right? That's always what we're doing in stats, right? We're taking something from a little sample and let that informing the whole deep truth. Right? You got a new medical treatment, like I was talking about last time. You want to know, does this new medical treatment work? Well, you try it on a few people, get the average for those people, and then considering, how good your data was, how many people you investigate, all that, you let that inform you about the true average on what this new medical treatment is going to do for the next 10 years on thousands of people. So you with me? You get this dichotomy? We're always looking at a sample and trying to find out the real truth. Like what will happen in the long run. What's true for the whole city. What, et cetera, right? That's always our goal. So these confidence intervals are always a confidence interval about the real truth. Like Bryce said, the real average consumption in the city. We don't know it. We didn't ask everybody in the city, did we? We don't got time for that. That's why we do statistics. You only got time to ask 250 people and then try your best to let that inform you about what's going to happen, what's going on in the whole city. Good. All right, what about this last part then? Coming on down here. If many groups of 250 are selected and studied and confidence intervals are formed for each group, about what percent of these will contain the true population mean? Yeah, that's just always 90, huh? That's always whatever here. And what percent will not contain? 10%. That's always 100 minus 90, right? We good on that? We're saying 90% of the time, we're going to catch the real mean. There is a real average for the whole city. We don't know what it is, but there's a 90% chance it's between 36 and 38. That's what we're saying. 90% of the time, we'll capture it. That's what this means. That's what a 90% confidence interval means. Here's number 2. The fitness center is interested in finding a 98% confidence interval for the mean number of days per week that Americans who are members of a fitness club go to their fitness center. Records of 249 members were looked at, and their mean number of visits per week was 2.1, standard 1.6. Round answers. Yeah.
Why is it T and not Z?
Why is it T and not
Z?
Z? Yeah. What's that? This first question?
Yes.
Yeah, it's kind of a long story, to tell you the truth.
So we're just always going to select T?
It's going to be T. Whenever you have the option, it's going to be T. Yeah. It's because the standard deviation comes from the sample and not the population. That probably doesn't mean a lot to you, huh? Yeah, it's a longer story. Just T is the right tool. T is the right tool. Yeah, so can you crank this one out? Go ahead and give that one a try. So 98% confidence interval. And so we're going to choose, what options does it give us there? Okay, so what's our X bar? X bar, yeah, the mean number of visits per week, 2.1. The S sub X, the standard deviation, 1.6. The N, the number of 249. And the confidence level, they want 0.98, don't they? Hit the buttons on the calculator there. I'm getting, they want 3 decimal places, 1.863 to 2.337. So then finally, and this is going to be the 98% and the 2%, right? Those are always that way. We good there? Is that coming out? That makes sense? On that, able to crank that out? It's probably a lot easier than all that probability stuff, huh? Is that good? Questions I can answer? All right. Okay, so question number 3. No, so now they're going to change. Things are going to change up a little bit on this one. Question 3. You are interested in finding a 95% confidence interval for the average number of days of class that college students miss each year. The data below shows the number of missed days for 10 randomly selected college students. Round answers to 3 decimal places where possible. Okay, so you got to put all this data in, guess where? In L1, like usual, yeah. So you got to put all those numbers in L1. So go ahead and first put all those. So this one's a little different. It's still a mean we're talking about on this one. So put all that data in L1. So if you've got it in L1, then go to Stat and Tests again, like usual. And we're going to choose, again, the, what's it called, T-interval. So it's the same test, T-interval. But this time we're going to choose data instead of stats. You know how we have those 2 options right at the top? Either data or stats. So this time we're actually going to compute the confidence interval from this data. Does that make sense what we're doing? So when they give you a list of data, you choose the data option when you go to the calculation. So choose the data option, and when you do, it'll ask you what is the list, and that should, it probably will say L1 already, and that's good. That's exactly what you want, because that's where you put the data list, right? You put it in L1, and so that's where it's going to go grab the data, is from L1. And then it's going to ask you frequency. Yeah, frequency is just 1. Just have a 1 there. What it means is how much frequency for each of those numbers. If those numbers were repeated, we're not going to mess with any of that this semester. So that'll always be 1 for us. Frequency will always be 1. It means like you could save time and say if you had 10 3s and 6 12s, you could tell it to repeat with a frequency, but we're not doing that. So just leave frequency 1. And then the confidence level, whatever they say, 95%. So 0.95%, and hit enter on that. And I'm getting it as well. So I'm getting, oh, this is T. This is still a T. This will always be a T distribution for these kind. And our confidence interval goes 2.3, so 175. To 7.225? 7.225, yeah. Is that coming out okay? Yeah, we'll just leave the frequency always 1. Everything we do this semester. Yeah. Is that good? Is that making sense? So now what's their question C there? If many groups of 10 randomly selected, same thing. Then 95% would contain the true population mean, and 5% will not contain the true population mean, like usual. They're just making sure we understand that there's a 95% chance that we're capturing the actual population mean, right? We're just taking 10 students, taking their average, and letting that inform us about the true average. 95% chance we're going to get the true average in our interval. Stats, and then put in the L1, the 1 frequency, and the 0.95 is your sea level. All right, so here's question 4. So again, they're giving us a data set, aren't they? So same kind of thing. Go ahead and put this data now in L1. Remember how to clear out your old data and then put this data in L1. Choose again, it's going to be the T distribution. You're going to do the same thing as last time. So first put the data in L1 and then choose stat and tests. Stat, tests, and go down to T interval, and then put in the information. And then you got to choose data again. Choose data, and then the list, that'll be the same. L1, it just stays L1. The frequency stays at 1, and the confidence level, what they ask is 98. So 0.98. So probably you only have to put in the confidence level, really, once you get that list in there. And I'm getting, see if you get the same answer I got, I'm getting 3 decimals again, 9.746. 9.746 to 21.968. Last part, it's always just whatever your confidence level, that means 98% chance that the true average is in our interval, 2% chance it's not. It will not. That's what we're doing with a confidence interval, right? Questions on that? All is well? So 8, let's try 8. Survey of 28 people were asked how much they spent on their child's last birthday gift. The results were roughly bell-shaped, mean of $47.50, standard deviation of $17.50. Estimate how much a typical parent would spend on their child's birthday gift. Use a 98% confidence level and give your answers to 3 places. So let's do that one real quick, and then in the end, I'll show you how to change it to this format. You might remember, might not, but we'll definitely go over that. So at first it's just a normal one. It's a mean, so we'll go to stat and tests, and we'll do T interval, and then when it comes to the data or stats decision, which one do we do here? Is it data or stats? Yeah, because this time we don't have a list of data, do we? We don't have a list of data. So you choose stats there, and then after you choose stats there, you come on in and you put the information in there. So hit enter. After, on the stats button, hit enter there, and then go down, and you'll go down and you'll have X bar, S sub X, and N, and then C level. And the X bar is the mean, the average, 47.5. And the standard deviation is 17.5. The N is the number of people, 28, and the confidence level is 0.98. So put all that in. And maybe you're getting what I got. I got 39.322, comma, 55.678. Is that coming out okay? But that's not what we put in those blanks, huh? We gotta like change it up somehow. But are we good to there? I want to make sure we're all okay to there first off before we make the change. So there's the first answer. I got the answer my calculator gave me for the confidence interval. So we good to there? Now, do you remember? We did it last time, and you guys never forget anything we do in here, I'm sure. What? Remember how to find how to change it to the the blank plus or minus blank format? Good, a lot of you do remember. Yeah, it's the average, huh? The first one's the average, and you get an average by adding them and divide by 2. Exactly, good. Yeah, so the first one you go 39.322 plus 55.678 divided by 2. That'll be the average, won't it? That'll be the middle of those two numbers. That's what they're asking. They want the middle of those two numbers. So that'll be the average. And so let's figure that out. I'll do it as well. 39.322 plus 55.678. Remember, you have to hit enter right here, and then go divide by 2, huh? And I'm getting 47.5. Did you get that okay? Again, make sure you hit enter before you hit divide by 2. If you just hit divide by 2 without hitting enter, it'll only divide the last number by 2 instead of the whole thing, like you want. Okay, so 47.5, that's what goes in the first blank. That's the average, the middle of those two numbers. And now that's what we think the average is. And then it's give or take some error amount, because we know our estimate from our sample is not perfect. We're trying to take a sample to figure out something about the whole population. We know our sample is not perfect. And so it's got some error. How do you figure out the error amount now? Yeah, exactly. Because remember, the 47.5 is in the middle, isn't it? It's the average. So basically, you're wondering how far back to the 39 number and how far forward to the 55 number, right? What do we add and subtract to get those two numbers? So yeah, so step 1 is you get the average. Step 2 is you just subtract, exactly. You subtract the 47.5 minus the 39.322. And we're getting 8.178. So that's the jump amount, isn't it? 8.178. That's the jump forward and backwards from the middle that'll get us the end points, the left and the right. So there we go. So there's the format they wanted it in. We're basically saying that we are 98% sure that the real average, money people spend on their kid's birthday. So we're saying we really think the average parent spends 47.5. Actually, you know what? We should have just known that was the middle, huh? Of course, that's always going to be our estimate. I didn't even think about that. Yeah, we could have just known that. Anyway, it's all right, we found it. So we really think the average is 47.5, give or take $8.17 and whatever that 8 is, 8.178 air. A little bit over an $8 air. We're saying we think the average parent spends about $47, give or take $8 about. That's what we're saying. That's the same thing as saying somewhere between $39 and $55, isn't it? It's another way to say the same answer. Is that good? Easy stuff?